This is an intro to chemical equations. Now, a chemical equation or a chemical reaction is a chemical change. Now, what that means, referring to chemical changes, is that something new is being created. Okay, so one or more new substances are forming as a result of this reaction. We use the chemical equations to represent these reactions so that we can actually see what things are reacting or combining to form that new substance. So let's look at take a look at the parts of our reaction. My reactants, actually let me do this. Here I've got a chemical equation, and we would read this as just simply A plus B produces C and D, or A plus B yields C plus D. So we're going to learn the different parts of this reaction so that we can identify how to read it, what the different terms are, what the different symbols represent, so that it'll be a little bit easier moving forward. So the first part of our chemical equation is what we call the reactants. Okay, the reactants are the original substances in my reaction. So if you think of this, think of them as sort of like ingredients that are found when you're making a recipe for a cake or something like that. These are going to be found before the arrow. So you'll notice in your chemical equation that's listed up above, there's an arrow. And we're going to refer to the left side of the arrow and the right side of the arrow. So when I say before, I'm really referring to the left of the arrow. Okay, the reactants are the original substances. So what I'm looking at here, I've got this A and B are reactants. So I'm going to go ahead and just label those with R's so that you know that those two substances, and those are going to be compounds or elements on the periodic table. Those are my reactants. My products are going to be on the opposite side of the arrow, and it's what's being produced. These are the new substances that are being formed when my original substances react. Okay, these are found after the arrow, or in other words, to the right of that arrow that's in my chemical equation. So when I'm looking at my chemical equation, I've got A and B. These were reactants. That means that C and D are products. So we've got reactants and I've got products. The plus sign in my equation is used to separate each substance. So we don't want to get confused. We don't want two elements to look like they are bonded together in the form of a compound unless they absolutely are. So I have these plus signs here that separate. It's telling me that this is one substance, this is a separate substance. They are not bonded together. Here I've got a plus sign separating C and D. It's telling me that C is its own substance, D is its own substance. They are not bonded together. They are completely separate. If there's no plus sign here, then we'll assume that the two substances are bonded together chemically, but when there are plus signs, that's telling us that they are separate from each other. And another part of this equation that's really important is the arrow. So the arrow tells me it actually separates the reactants from the products. Okay, now think of the arrow as like a equal sign in your mathematical equation, like 1 plus 1 equals 2. Well, the equal sign tells you that when you combine 1 and 1, you produce 2. Well, in the chemical equation, we don't necessarily have an equal sign, but the arrow is really essentially an equal sign. It tells me what's being produced when I combine a couple substances. So when I combine A and B, I'm producing C and D. So think of this as when I add these two together, I equal these two things. Now we don't refer to it as equal. We might refer to it as, we might say yields, or it forms, or produces. So we could read this equation: A plus B yields C plus D. Or 3A plus B produces 4C plus D. Something along those lines. All right, the coefficients. Coefficients are the large numbers that are in front of the symbols or the compounds. Okay, so when I look at, I misspelled large, there we go. When I look at my equation, back up at the top, I see it says 3A plus B yields 4C plus D. So the numbers that are, the large numbers that are in front of the substance, like the 3 and the 4 here, are coefficients. Now remember, a lot of times when there's not a number seen, it's implied. So in front of B, there's no coefficient, so it's implied that it's a 1. Over on the right in your products, D, there's no number, no coefficient in front of it, so it's implied that it's a 1. So my coefficients would be 3, 1, 4, and 1. So I'm looking down here, the coefficients. The coefficient in front of A, we said was a 3. The coefficient in front of B was implied as a 1. The coefficient in front of C was 4, and the coefficient in front of D was also implied as a 1. All right, the next part of a chemical equation is the the subscripts. I'm going backwards. Subscripts. So we already know what a subscript is. The subscripts are the small numbers that are at the bottom right of a compound or an element. And those tell me how many atoms of that specific element I have. Or in other words, it tells me the ratio. So it tells me the number of atoms or ratio depending on what kind of bond it is. Some other symbols that you might see. You might see S in parentheses. S just tells you that that substance is a solid. So rather than writing out the word solid, it's just going to abbreviate it with an S. You might see a lowercase l. L tells you that that substance, whether it be an element or a compound, is a liquid. G represents a gas. And AQ means that this substance is aqueous. And what that means is that substance, that element or compound, whatever it may be, is dissolved in water. So it doesn't necessarily, yes, it is a liquid, but it's telling you that substance is dissolved in something else. So it's not pure 100% one particular element. And the last one here is the delta or the triangle. Anytime you see this delta here, that tells you that heat is being added. Heat is going to be added to a system. Okay, so let's take a look at another form of equation. This is kind of just a practice one, just to kind of give you an idea. Here I've got a chemical equation, and the chemical equation says cake mix in a solid form plus water as a liquid plus 3 eggs as a liquid plus oil as a liquid produces or yields, when I add heat to it, a cake. Okay, so remember we said that a chemical equation is like the ingredients to baking something or making some kind of a food or a dish. Okay, it tells you, it's like the recipe that tells you how to make the substance. Well, in order to make a cake, I need to take cake mix and add water and add eggs and add oil, and I produce cake when I add heat to all of that. Okay, so this is just another way to look at a chemical equation to help you understand what the whole purpose or the whole point of this is. So remember, we've got our equal sign. So one of the first things you should do is identify the equal sign, and remember that everything to the left of the equal sign, everything that comes before the equal sign, is what we call the reactants. So we're going to go ahead and label those as reactants. So the cake mix is a reactant, the water is a reactant, eggs are reactants, oil is a reactant. Anything to the right of the equal sign is what we call a product. So how many reactants do I have? I see cake mix, water, eggs, and oil, so that means that I've got 4 reactants. How many products? Well, I only see the one over here, and that's my cake, so that is 1. Why is there a triangle or a delta? Remember, this is referred to as delta. We don't really call it triangle. Yes, it is a triangle, but we don't call it that. We call it delta. And remember, the delta means that heat is added. In order to make my cake, I need to put it in the oven. I need to add heat to it. Okay, what is the coefficient in front of water? All right, so when I look at water, I don't see any coefficient here. So remember, it's implied that it is a 1. Okay, in front of cake mix as well, 1. In front of eggs, I've got 3. In front of oil is a 1. And in front of cake, I've got 1. So the coefficient in front of water is 1. And the coefficient in front of eggs is 3. How many substances are liquids? So now we are looking for a substance that is labeled with an L. Solids are going to be labeled with an S. Gases are going to be labeled with a lowercase g. So when I look up here, I see cake mix is a solid, water is a liquid, eggs are liquid, oil is a liquid, cake is a solid. So I've got 1, 2, 3 liquids. All right, how many solids do I have? Well, I've got cake mix is a solid, and the actual cake is a solid. So that's 2 solids. And looking for any gases, I think that covers everything. So we don't have any gases in this equation. All right, so now let's look at a real equation. That one was just an example. So in this equation, I have 2H2 gas plus O2 gas yields or produces 2 H2O molecules in the form of a liquid. Okay, so here's my arrow, which means everything to the left of the arrow is what we called a reactant. So this is a reactant, this is a reactant. Everything to the right of the arrow is a product. So how many reactants do I have? I've got 2 reactants. How many products? I've just got 1 on the right side of the arrow. List the coefficients in order from left to right. So the big numbers in front of the compound or the element, I see a 2 here. I don't see anything here, so remember it's implied that it's a 1. And then over here I see a 2. So in order from left to right, we got 2, 1, 2. What phase of matter are hydrogen and oxygen? So remember, in parentheses, it tells me the phase of matter that they are in. Hydrogen is a gas. Oxygen is a gas. H2O, we know what H2O is: water. Water is a liquid. So what phase of matter are hydrogen and oxygen? They are both gases. And what phase of matter is water? It is a liquid. So when I mix two gases together, I get a liquid. All right, so that was our brief introduction on chemical equations. We're going to continue to build on this. The most important part is understanding how to read it, and then from there, we'll just continue to build on those skills.